Okay, welcome to Wednesday, your e-learning lesson. You're to take notes over this and tell me what you've learned, and then take a picture of it and send it back to me. All right. So, can you taco tongue or and evil eyebrow? So, evil eyebrow means you raise one eyebrow up and you look at somebody with an evil look, and taco tongue means can you make your tongue into the form of a taco? All right. So we're going to go through part of this. I'm going to give you part of this because we're not in class to do it. So, some people believe that the ability to taco tongue and evil eyebrow is something that you are born with. Is this true? Are the two abilities somehow related? Well, this is just a generic example of what we can do. So, let's go through this together. I'm going to give you some of the information to start with. So, let's say we collected this information 0, 6, 1, 1, 0, 10. So altogether, there are 18 people in this form here, okay? On the top, we have the evil eyebrow. And if you just kind of cross this out and look down, there are 6 that say no to evil eyebrow, 2 that are sorta, and 10 that are definitely yes, okay? And then on the left side here, we have the taco tongue people. Okay, so if we get rid of the evil eyebrow part and we just look to the right, there's one that sorta can do it, and there are 17 that definitely can do it. Okay, so that's how this chart works. Let's go ahead and answer some questions because I think this will help us as we progress. Okay, so let's go into question number 2. Suppose that we randomly choose a student from class. Find the probabilities that we have here. Okay, so the probability that there is no evil eyebrow. Okay, so on this one, look at the no for evil eyebrow. And how many are there? There are 6 no's. This is the no column for evil eyebrow. Don't look at the taco part of this, okay? So if we're just dealing with evil eyebrow, we're looking at the totals here for no, sorta, and yes, all right? So again, altogether, there's 18. So there's 6 no's for evil eyebrow, so 6 out of 18. And if you wanted to, you could reduce that to 1/3. All right. So the probability of sort of evil eyebrow, well, that should be, again, 2 out of 18, or 1/9. Again, don't look at the taco stuff. Just look at the evil eyebrow information. All right. So now let's look at the third one here. The probability that you have no evil eyebrow or sort of evil eyebrow. Okay? So let's look at, we're adding these, and no evil eyebrow is going to be 6 out of 18, which we already figured out. And then we have the 2 out of 18, which is the sort of, okay? And we add those together, and we get 8 out of 18, or 4/9, okay? So that's the answer for the probability of evil or. So what does this mean? Mutually exclusive. We'll talk about that here in a minute, okay? And not mutually exclusive down here. We'll get to that in just a minute. So let's do number 3. Suppose that we randomly choose a student from class. Find the following probabilities. The probability of yes to having a taco tongue. All right, so let me erase some of this for a second. Okay, so we're just dealing with the taco part, yes and no. So if we look down, there's only 1 that's a no, and there's 17 that are yeses. If we're going this direction, we're not worried about the evil eyebrow part. So the probability that yes, you can do a taco tongue is 17 out of 18 people. And now let's go back to understanding the yes for evil eyebrow. The yes for evil eyebrow, there are 10. Remember, just look down for the evil eyebrow and look across for taco. All right. So now the yes for a taco tongue or yes for evil eyebrow. Now it says not mutually exclusive here. So here's what this is talking about. You see that we have the word or, which means add. All right. So if we're really adding, you need to look at what we're adding. So the probability of the taco tongue was 17 out of 18. All right, now look up here. In that 17 out of 18, you also have the 10 that you counted that are included in the evil eyebrow. And so when we do plus the probability of the evil eyebrow, that's 10 out of 18. Well, you can't count those 10 twice. They're only counted once. So you have to subtract that 10 that you took out, or that you put in there. They're in the 17, okay? You already included them in the 17 here, okay? And you're adding 10 for the probability of the evil eyebrow. So the 10 are included here. They're also in the part for the evil eyebrow. So you have to subtract them because you can't count them twice. That's what it means to be not mutually exclusive. And it's really kind of hard to understand that part. So the answer to this is still 17 out of 18. Okay? Okay, so let's go to, and let's keep this going. Suppose that we randomly choose a student from class. Find the following probabilities. So you'll have to look at those numbers again, but I'll just give them to you as we go through this. The probability that yes, you have an evil eyebrow. Well, there were 10 of those that had an evil eyebrow. 10 out of 18. Okay? So if you would go down to the next one, yes, there's an evil eyebrow, given the person is a yes for taco tongue. So what that is saying is, in the yes row for the taco tongue, that's what the given part means. There are 6, 1, and 10 in the row for being able to do a taco tongue. All right, so what's the probability of an evil eyebrow out of the row of all the people who can do the taco tongue? Well, that was the number 10. Okay, so out of those 17, you have 10 out of 17. So the given part is telling you what group of, what category, or what row, or what column you need to be looking at. All right, so let's do this next one. The probability that yes, you have an evil eyebrow, given the person is no to a taco tongue. Okay, so let me write these up here so we can remember what they were. This is your box that you had on the other page. So these were no and these were yeses for the taco tongue. So this is saying given the person is a no. So we are only, for the taco tongue, so we're on the taco side, we are only dealing with the no row. Okay? So what's the probability in that row? What number is a yes for the evil eyebrow? Well, the yes for evil eyebrow is a 0. Okay? So you have 0 out of how many in this row? There's only 1 in that row, and it was a sort of. So you had a 0 out of 1. So there's a 0 probability that you're going to have pick an evil eyebrow, given that the person said no for a taco tongue, because there weren't any that said yes in that column that said no for a taco tongue. This is pretty hard to understand, but hopefully the chart gives you a little clarity. Okay, so let's go on to number 5. So number 4 is asking us, what can we tell about taco tongue and the ability to evil eyebrow? Well, based on that last one, if you can't taco tongue, you can't have an evil eyebrow based on the 18 students that they used. That's what that means. So number 5 is just trying to explain what it is you found. All right, key ideas. Let's look at this. Mutually exclusive events are mutually exclusive if they cannot occur together. Example, can't be a junior and a senior at the same time. That's right. You can't flip a coin and get both heads or tails. Those are mutually exclusive events. So, or problems means you add them together. If the events are mutually exclusive, then the overlap will be 0. Okay? Conditional probability, written like this, means that probability of A plus the probability of B minus the probability of A and B. Cover up the sections you no longer need, then answer the question. Okay, so let's go to the next page. and try to put this together. Students at a small high school in Michigan were asked, which subject area do you prefer, math or English? So at the top we have all the grades, freshmen, sophomore, junior, seniors, and the totals of how many there were. People who liked math, people who liked English. Okay? So you have, these are not mutually exclusive necessarily. Okay? So you can be a freshman and like math, and you can be a freshman that likes English. Okay? But those numbers don't necessarily always go together. So part A, if a student is, these have the answers here for us, so you can see what they're saying. All right? So if a student is randomly selected, what is the probability that they are a senior column, who prefers math? Okay? Well, that's 40. They're a senior and they like math out of the total of how many students they've looked at. Okay? There are 119 people that like math, 131 that like English. Altogether, there's 250. Okay? Same thing with the bottom. If you take 64 and 60, 65 and 61, you're going to get up to 250. All right? So let's make sure we understand the charts. If a student who prefers math is randomly chosen, and again, we're only looking at this row up here, the math row. If a person who prefers math is randomly chosen, what is the probability they are a freshman? Again, out of this row, you get 20 out of the total 119 because we're only dealing with people who like math. And then part C is you have a freshman student is randomly chosen. What is the probability they prefer math? Okay? Okay, you're only looking at the freshman column. You're choosing a freshman. And out of all the freshmen, what's the probability they prefer math? So out of all these freshmen, 20 out of 64 prefer math. All right, so I'm going to pause this and clean up all this mess on this table. Okay, so this next part's fairly simple. You have math and a freshman. Suppose a student from this high school is randomly selected to find the following. The probability that you are a student who likes math and you're a freshman. Well, 20 out of 250. Part B, English, given they are a junior or senior. Okay, so now we have a given. We are only going to look at the junior and the senior columns here. So out of those, how many people like English? And if you look at that, you have 52 out of the total, which is 126. So every time you have a given, only look at those values. All right, the next one, part C, is the probability that you have. I'm going to clean this up. Okay, part C. The probability of a sophomore, 60 out of 250, or, meaning plus, a senior, 61 out of 250. So you add those together, that's where they get the 121 out of 250. All right, so now let's look at part D. The probability that you're a sophomore, 60 out of 250, or you like math. Now, be very careful. This is conditional. We're in the sophomore column, okay? And how many people like math? Okay. So you've already counted the 25 once when you say you're a sophomore. So 60 out of 250. You've already counted that 25. Now, what's the probability that you like math? Well, that's 119 out of 250. Okay? So you have to subtract the 25 that were overlapping. Okay, so again, let's make sure we get this. Out of the sophomores, you just go right. The first thing is always what you think it's going to be. There should not be a problem about figuring some of these things out, the first one. So the probability that you pick a sophomore is going to be 60 out of 250. And then go ahead and do the next one. The probability that you pick a math student Well, that's going to be 119 math students out of 250 total. The issue is if you have a chart, if you can look at it and see what is overlapped on the two circles that you've made, then there shouldn't be any issue with understanding what you've duplicated. You can't count 25 students twice or three times, whatever. So in this case, it's always going to be twice. So you have to subtract that 25, and when you do that, you'll get the 154 out of 250. So the best way to do this stuff is try to notice if something is overlapping, and you can tell up here in the chart that you have these two circles overlapping. And what overlaps is what you have to subtract. So that should help you when you're doing some of the other charts on your homework. So good luck with that. Make sure you send me a picture of these notes immediately today, and work on the homework and send me questions that you might have. And then it's due by midnight Thursday night. All right, so I'll try to send out answers to certain homework questions on Thursday for you. Okay? All right. Talk to you later.